So welcome to lecture 13. In the last lecture we have seen the solution of homogeneous equation, that is the ordinary linear differential equation. Now in continuation with it, let me take one problem where the roots consist of complex conjugate, distinct and multiple. So how can we solve that? Then after that we'll go for the solution of non-homogeneous linear differential equation. Okay. So suppose let me write that x raised to 5 means d5 x of t upon dt raised to 5 plus 9 d4 x of t upon fourth order differentiation plus 32 third order differential equation plus 58 second order differential equation, okay, plus 56 dx by dt, obviously this is x of t, plus 24 x of t, which was equal to 0, and initial conditions are given as x what is it, x4 of 0 means what? This will be d4x by dt raised to 4 of 0 positive is 0. Then d3 x of 0 positive dt cube is 4, no? Which is 1. Then x3 prime of 0 plus is minus 1, sorry, x3 is 1, x4 is 0, yeah, x3 is 1, x2 is say minus 1, this is 2 only, okay. X dash of 0 positive is 0 and x of 0 positive is, let's say, 1. Okay, so let us write the characteristic equation first. So what it will be, p raised to 5 plus 9 p4 plus 32 p cube plus 58 p square plus 56 p plus 24 is equal to 0. So there are 5 roots. Out of that, 2 roots are complex conjugates, so it will be minus 1 plus minus j. 2 roots are repeated, third and fourth, which are at minus 2, and fifth root is at minus 3. So how will be h of p? Your characteristic equation will be p plus 1 plus j, p plus 1 minus j, p plus 2 square, and p plus 3. Okay, and what will be the solution? X of t will be it is here one constant m1 e raised to sigma, that is minus t cos t plus m2 e raised to minus t sin 2t plus k1 e raised to minus 2t plus k2 into t e raised to minus 2t plus k3 e raised to minus 3t, right? And then we can evaluate it at x of 0 positive. You can evaluate at x dash of 0 positive, x double dash of 0 positive, x third dash of 0 positive, and x 4 dash of 0 positive. I mean, you take the differentiation of first order differentiation, second order differentiation, third order, fourth order, and you put it that you evaluate at 0 plus, you will get some constants, right? And if you solve, you will get the value of m1 is 0, m2 is, you do at your home to get it this answers. M2 is this, k1 I got it 1, k2 is 1 by 2, and k3 is 0. Okay, So the equation or the solution x of t will be m2. So this m2 is 3 by 2 e raised to minus t sine t, no, sine 2t plus e raised to minus 2t plus 1 by 2t e raised to minus 2t. 2t, no? So it is, yes, e raised to minus 2t. Okay. So this way also you can do if it consists of the number of different roots. Okay. Fine. Now next we'll go with the solution of non-homogeneous equation. So already we defined it. What is the non-homogeneous equation? So what is non-homogeneous equation? Which where where it consists of the forcing function. So let me write the generalized form: a n dn x of t dt raised to n, and this way plus a1 dx of t upon dt plus a0 x of t, which is now not 0, which is some function f of, and that function let me call it as forcing function, right? So if this is the case, the solution, the total solution x of t will be consist of two parts. One will be your complementary solution and next will be your particular solution. So complementary solution is the solution which we will obtain by putting the forcing function is equal to 0, and the particular integral is, we have to find it out separately, which will be in the form of forcing function, and that will be expressed in exponential form generally. Okay. So for example, say I have the complementary function f of t is like this: alpha into e raised to bt. Okay. So here let me consider alpha and beta are my arbitrary constants. Okay. Alpha and beta are my arbitrary constant. If this is the case, what will be the particular solution? So basically, the method for obtaining the particular solution is appropriately can be called as the method of undetermined coefficients. Okay, undetermined coefficients, or you can call it as unknown coefficients. Okay. So for this, what will be my particular solution? Xp of t will be in the form of a into e raised to beta. And what is that a? A is the unknown which is to be obtained to compute. This is my particular solution. Okay. So to determine it, let us see, let us write a generalized form again. So generalized we have already written, that is a and d and rest to and all. So suppose my form will be what is particular solution? Xp of t, we assume that it is a e raised to bt. So let me put it in that, which was a n dn dt raised to n. X of t was a e raised to bt plus a, not this, will be subscript of a n minus 1 dn minus 1 dt raised to n minus 1 a e raised to bt, like this. What to do? A1 d dt of a e raised to bt plus a0, correct? So this is a0 a e raised to bt, and which is equal to your forcing function. So what is the general forcing function? Any function, try to express it into exponential form. So alpha into e raised to beta, this way. Okay. Let me rub it and write a into e raised to bt, this way. Okay. So if I'll do, what it will be, a e raised to bt, it will be common, so it is a n b raised to n plus a n minus 1 b raised to n minus 1 plus a1 b plus a0, which is equal to alpha into e raised to beta, and this e raised to beta and this a raised to beta goes. So what is that? Method of undetermined coefficient, which is a will be equal to alpha, and this is polynomial, and what this polynomial is will be, let's say, in terms of beta. So this way you can obtain the undetermined coefficient. Okay, and provided that h of b, your characteristic equation must not be 0, then only there will be the existence of non-homogeneous solution, existence of solution of non-homogeneous equation, I'm sorry. Okay, let us see with example. So suppose one example I'll take it, x dash of t plus plus 3 x dash of t plus 2x of t, 2x of t, which is, let's say, 4 e raised to t. Now very simple. So first let me find out what is the characteristic equation. H of p is equal to p square plus 3p plus 2, and what will be the roots? The roots will be p plus 1 and p plus 2. First you can find out the complementary solution. So what is the complementary solution for it? It will be k1 e raised to minus t plus k2 e raised to minus 2t. And now I would like to obtain what is my k1 and k2, but I will not do that, because in this initial condition will be given for the total solution, right? So the initial condition for the total solution, x of 0 plus is 1 and x dash of 0 plus it is minus 1. Okay, so let me find out now. The complementary solution has been written. Let me write, or let me find out what will be my particular solution. And my particular solution, how can we find out? A into e raised to beta t, and value of a is to be obtained as alpha divided by h of b. That is, either I can write whatever the polynomial I have written, p evaluated beta. Okay, so alpha, what was the h of p? P square plus 3p plus 2, and it was at beta. Beta is 0 in, no, beta is not 0, beta is 4. So this alpha is how much? Alpha is, so beta is 1, sorry, I'm sorry. This will be, beta will be 1. Okay, and alpha is 4, so 1 plus 3 plus 4 is 6, so it will be 2 by 3. So value of a is 2 by 3. So your particular solution will be 2 by 3 into e raised to beta t. Beta is 1. Fine, this is the particular solution. So what will be my total solution? X of t will be complementary solution, which is k1 e raised to minus t plus k2 e raised to minus 2t plus 2 by 3 e raised to plus t. Okay, now after obtaining the total solution, then you evaluate for the initial conditions. Okay, so let us evaluate at 0 plus, so it will be k1 plus k2 plus 2 by 3, which is 1. Okay, now let me compute x dash of t also, which will be minus k1 e raised to minus t minus 2 k2 e raised to minus 2t plus 2 by 3 e raised to t, and this also evaluated t is equal to 0 plus, so which will be minus k1 minus 2k2 plus 2 by 3, which was how much? 1. So if you solve it, If you solve it, what you will get, value of k1 will be -1 and value of k2 will be 4/3. Okay, so total solution x of t will be minus e raised to minus t plus 4/3 e raised to minus 2t plus 2/3 e raised to plus t. This way you can find out the solution if there is the presence of excitation. Okay, now next we'll go. Now next for next forcing function, suppose I'll take it. Next forcing function is a constant forcing function. Okay, so suppose my f of t is equal to alpha, that is suppose only constant. Okay, so how can we solve that? So if it is only constant, then whatever may be, try to express in terms of exponential form. So what will be your exponential form? F of t will be alpha e raised to 0t, where my beta will be 0, and assume the same equation what we have, which was p square. What was the equation? Let me see here only. What was my equation? Was p square, characteristic equation was p square plus 3p plus 2, which earlier we have seen. Okay, so instead of that 4 e raised to t, let me take it which is equal to alpha. Okay, so okay, now let us find out what is the total solution x of t. Complementary solution, already we got it, k1 e raised to minus t, k2 e raised to minus 4t, and I have to write xp of t. Okay, so what will be my particular solution? xp of t will be a e raised to beta t, and I would like to get what is my a, and a can be calculated as alpha divided by the characteristic equation evaluated at b. Beta is 0, which will be alpha divided by p square plus 3p plus 2, means p will be evaluated at beta, which is 0. So this is 0 0 2 will remain, so alpha is 4 and 2, so which will be 2. So your total solution x of t will be k1 e raised to minus t plus k2 e raised to minus 4t plus 2. And next, to find out k1 and k2, apply the same process which we have recently done. Okay, I'll not go detail into it. You know, you can do it. Okay, now next, what if it will be the complex conjugate? So if my forcing function is alpha or alpha e raised to j omega t, okay, which is alpha cos omega t plus j sin omega t. Okay, and what will be my particular solution? xp of t will be, this will be real part of xp1 of t plus j into imaginary part of xp1 of t, that I can write. Fine, and from that I can select what will be my real or what will be my imaginary. For example, if f of t, I have alpha cos omega t. Okay, so what will be my particular solution? x1 of t will be real part from find out xp of t, or if alpha sin omega t, you find out imaginary part from your xp of t. For example, let us take it, let us clear with this example. So suppose I have x dash of t plus 5x dash of t, okay, plus 4x of t, which is equal to 2 sin 3t. Fine. So now what will be my particular solution? So xp of t you can write as a, okay, e raised to j omega t. So j omega is 3 and t, so that way you can obtain it. Okay, And what is my alpha now? Alpha is 2, beta is J3, and this you can put A will be equal to alpha is 2, and your characteristic equation is same. Let's take P square plus 3P plus 2 and put it P is equal to beta, which was 3J, so it looks like 2 minus 9 plus 15J plus 2. Okay, whatever it is, you can get it this, then you will get it real and imaginary part here. Okay, so suppose A plus JB, some constant here, let us take it constant means say M. Okay, so then what will be, what you can write as A plus JB, you can express in terms of the magnitude into angle of it, so which is e raised to j tan inverse of it, tan inverse of imaginary divided by real. And from that, if forcing function is alpha sine t or 2 sine 3t, then took it the imaginary part, that is sine part. If forcing function is cosine, then you take it the real part from this representation. Okay, so this way the solution of ordinary differential equation for the homogeneous or non-homogeneous, if you know this much information is enough for us to solve the circuits.